Hi everyone, welcome back. We are going to pick up where we left off from last class, and that was simple interest problems. All right, guys, let's take a look at your notes. So Marty received an inheritance of 60 grand. She invested part at 7% and the rest at 10%. Her total annual income from the investments was $5,100. Find the amount she invested at 7%. And you know what? I'm going to add to this, find the amount at 10%. So essentially, I want us to find all of that. Okay, so let's write our chart. We have principal, we have rate, we have time, and we have interest. Luckily, our chart will look the same every single time. Every single time we do these simple interest problems, they're always going to look the same. We will have 3 rows. We are going to have an account 1, an account 2, and a total. Okay, sorry my lines are so squiggly and messed up. We are told that Marty received an inheritance of 60 grand. When you think about that and you're thinking about investing all 60 grand, I want you to consider that that's principal, that's total principal. So the $60,000 will go here for the total investment for both accounts. Next, you're told that she invested part of that money at 7% and the rest at 10%. So let's call the rate for the first account 7%. And recall that we're going to write that as a decimal. So that's going to be 0.07. The second account grows at a rate of 10%, so we're going to write that as 0.10. Every time you do these problems, it's always going to be annual income, so it's always going to be 1 year. Don't overthink this, it'll always be 1 year, okay? Next, we're also told that the total annual income from the investments, so that means the amount you earned, which is interest, is $5,100. So we're going to put the $5,100 here for total interest. Not bad, right? Straightforward. We want to find the amount invested at each rate, which means we want to find the amount invested in each account. So let's call this A and let's call that one B. Having said that, we can easily fill in the spot here for interest for account 1 by noting that principal times rate times time is interest. So for the first account, we'll have 0.07A. For the second account, we'll have 0.10B. Voila. Just by looking at our chart, we have our 2 equations. We have the one based on investment, and we have the other one that's based on interest. It's always helpful to write out both equations before we manipulate them. As a reminder, you could choose to use substitution, or you could choose to use elimination in solving this system. I personally enjoy elimination, so that's exactly what I'm going to do for this particular problem. But if there comes a point where you're like, you know, I would really like to see substitution, then let me know and I'll do it that way instead. So now that we're set up to use elimination, I am going to choose to multiply the top equation by the opposite of this coefficient. I'm going to use the opposite of this number so that my A can cancel. So I'm going to multiply by a negative 0.07. As a reminder, when we multiply, we must distribute to all 3 terms. You cannot just pick and choose. You can't do half the problem. So if I distribute this negative 0.07, I get negative 0.07A, negative 0.07B is equal to, and then when we multiply those together, we get negative 4,200. Okay, and you can verify that. You can take your negative 0.07, multiply it by 60,000, and you should have a negative 4,200. Next, we're going to bring over our second equation because we did not have to multiply by anything in order for my terms with A to cancel. Notice these are opposites. They eliminate each other. One is a negative, one's positive. We know we did the right thing. Next, we have a negative 0.07 plus 0.10. Be careful as you punch this in. I just want to show you. You want to make sure you've got the negative 0.07 and then plus 0.10. That'll give you 0.03b. Be super careful as you do this math. I've been finding that there have been many errors based on not plugging it in correctly with all your signs. With our last column, we have negative 4,200 plus 5,100. If you don't see a sign there, it's a positive number, so we're adding, and that gives us 900. Hopefully that's clear. Next, we want to isolate b, so we divide by 0.03. So if I divide by 0.03, I'm left with b is equal to 30,000. Good. With b being 30,000, that refers to the second account. The second account grows at a rate of 10%. So we know that in account 2, we have $30,000. Now think of this logically. If I started with 60 grand and 30 grand went into the second account, then it must be that 60 minus 30 is 30, so we have 30,000 in the first account as well. So as a reminder, I'm just going to put here that a plus b is equal to, to 60,000. And if a plus b is 60,000, but b is 30,000, you know that a has to be 30,000. So my answer, you could write account 1 equals 30,000, account 2 equals 30,000. I'm going to write 30,000 was invested in each account because they happen to be the same. So why not? Okay, and we're done with this problem. They all are identical to this. So I don't want you to overthink this. I want you to have your notes next to you as you work through the homework. All it is trying this again and again and again and making sure that your practice is perfect. The biggest thing is those decimals. Be super careful with your decimals. Be careful with how you punch them in, etc., etc. Brittany, your tests are electronic moving forward this semester, so I can't see your work. So just make sure that you have everything organized. If there's a situation where you're like, I wrote it correctly on my paper, but I didn't type it in correctly, then just show me that work. Okay? Let's move into mixture. Mixture is fun. All right. For our mixture problems, we're always going to use the same setup. Box plus box is equal to box, right? We're going to use this setup. In terms of your equations, we're actually going to have two equations, and I only have one of them here, but I'm going to introduce another one. So one of your equations is the value of item number 1 plus the value of item number 2 is equal to the value of the mixture. Okay, cool. But you have two equations that we need here because we're actually going to use two variables whenever possible. Your second equation is going to be the amount of number 1 plus the amount of number 2 is equal to the total amount of mixture. Okay? So you have two equations. You have the amount equation, or your weight, and you have the value equation. Now I want to have a quick conversation about value because I think sometimes we way overthink it in terms of these mixture problems. So when we think about the value of an item, I want you to think about what it looks like when you go to the grocery store, for instance. So let's say that you wanted to go to Wegmans, right? And you decided that you wanted to purchase some Honeycrisp apples because they're delicious and why not? So you look at the bin of Honeycrisp apples and you're thinking to yourself, okay, how much is this going to cost me? Well, you have to find two pieces of information, right? The first thing you need is the cost per pound. So you have to figure out how much it costs for every single pound of those Honeycrisp apples. So what if I told you that it was $2.59 for every pound of Honeycrisp apples? So you know that each pound is $2.59. Okay, that's cool. Now what if I tell you that I want 5 pounds because I'm making some pies at home? If every pound costs $2.59 and you need 5 pounds, wouldn't you multiply those together? So you would take your 259, you'd multiply it by the 5, and you'd find that the value of the Honeycrisp apples is $12.95. So now you know exactly how much to pay. Value is exactly that. You take the cost per unit and you multiply it by the amount. Even if it's solutions, for instance, acid solutions, right? You're going to take the concentration of that particular solution and you still want to multiply it by its amount. So remember, value refers to cost times amount or concentration times amount. Remember that. Let's go back to the notes. I have the formula here in case you're like, huh? And I'm going to write here, think Honeycrisp apples. All right, sweet. Let's take a look at number 13, and I want to show you how this mixture problem is set up and how nice it is in terms of writing our two equations, given that we know exactly what those two equations have to be. So let's draw our boxes, and then I'll read the problem and we'll figure out where everything goes. In terms of the setup, please, please, please put everything exactly where it says it's supposed to be. You don't want to overthink this, okay? So JB owns a nut shop. He sells almonds for $6 per pound and walnuts for $5.20 per pound. He receives a special request from a customer who wants 30 pounds of a mixture of almonds and walnuts that sell for $5.50 per pound. Determine how many pounds of walnuts and almonds should be in this mixture. Okay, no big deal. Let's organize the information we're given. I want to call this first box my almonds. I like labels in terms of our charts here because it helps keep everything organized, and I think you should do that too. So my first box here is almonds. My second box pertains to walnuts. And my third box is the mix of the two, right? It's an almond-walnut mix. Okay, cool. Notice that for each of these, we have a cost in terms of dollars, and that for each of these, we should have a weight, and that weight is in terms of pounds. So we label everything. We literally label everything. Now let's put things where they belong. We don't want to overthink this. He sells almonds for $6 per pound. Okay. $6 per pound. And walnuts for $5.20 per pound. Okay. He receives a special request from a customer who wants 30 pounds of a mixture of the two. Okay. 30 pounds of the mix. You see where I placed it? And 30 pounds of a mixture of almonds and walnuts that sell for $5.50 per pound. Okay, no big deal. As a quick note, you'll know that this mixture should make sense because this value, this number, this cost or concentration will always be somewhere between these two numbers. You're mixing a more expensive nut with a cheaper one, and it's going to be somewhere in between. All right, I want you to think of it that way. Your mixture will always be somewhere in between these two values. We now want to find the number of pounds of almonds and walnuts. So why don't we call this one A for almonds, and why don't we call this one W for walnuts? Okay, we have two equations. The first equation is the amount of almonds plus the amount of walnuts equals the total amount in the mixture. Okay. So the amount of almonds plus the amount of walnuts is equal to the total amount in the mixture. A plus W equals 30. How nice is that? That takes care of the first equation. The second equation is value. And remember that value is cost times amount or concentration times amount. So the value of my almonds is going to be 6A. 6 times A is 6A. The value of my walnuts is 520W, so 5.20 times W. The value of my mixture is going to be 550 times 30. So let's take our calculator, and we want to do 550 times 30. If we take 550 times 30, we would get 165. Okay, I'm going to make a note. Value is $5.50 times 30, which is 165 bucks. Okay, just in case you're like, huh? How did you get the 165? That's how we did it. The value, cost times amount. I love it. I'm going to rewrite the system here. So we have 6A plus 520W is equal to 165. And now we're right back to where we started, which is, do I use substitution? Do I use elimination? Whatever your heart desires. For the sake of just showing you again what substitution looks like, I'm going to use at this time. But generally speaking, I prefer elimination. Not that you have to, that's just my personal preference. So if I use substitution, so I'm going to write here, substitution method, I'm going to take A plus W is equal to 30, and I'm going to subtract, let's subtract A. It doesn't matter which one. So W is now 30 minus A. So now that W is 30 minus A, that means in my second equation, wherever I see W, I will replace it with a 30 minus A. Sometimes it's helpful to circle that expression and then kind of make a note that this whole thing is going right in place of that W. It's being substituted in. So that gives us 6A plus 520, and instead of W, we replace it with what we know W is, and that is 30 minus A. And we see that that's equal to 165. So all we do is we rewrite the equation, but we substitute 30 minus A for W. Do you see the substitution? And now let's distribute and solve. So we get 6A plus 5.20 times 30 gives me 156. 5.20 times a negative A is a negative 5.20A is equal to 165. Next, we're just going to combine like terms. 6A minus 5.20A, when you punch that in, 6 minus 5.20 will give you 0.8A. So we have 0.8A plus 156 is equal to 165. Next, we're going to subtract the 156. We get 0.8A is equal to 9. And now all we have to do is divide. So we divide both sides by 0.8. And 9 divided by 0.8 gives me 11.25. While that is fantastic because we found one of the answers, we know we are not done with this. Simply for the fact that we have an A and we have W. So we have two unknowns, which means we need two answers. What I would recommend to all of you is that if you know that A, the pounds of almonds, is 11.25 pounds, then why not take this answer and plug it into this equation. The number of pounds of walnuts is going to be 30 minus the pounds of almonds. So if I take 30 minus 11.25, we see that the walnuts has to be 18.75. Not bad, right? So let's write our answer. Almonds equals 11.25 pounds and walnuts equals 18.75 pounds. Always clearly label your answer so that when you go ahead and you type in your work into Lumen, you'll know exactly what goes where. You won't accidentally switch them. All right. Beautiful. Let's turn the page and keep going. I really love mixture problems because it's always the same thing. Box plus box equals box, and you always have the same two equations, your weight and your value. Awesome. I love it. Hyder, you said use elimination, and you got that A was 11.25, which is beautiful. So if you're using elimination and you got A is 11.25, take this answer and plug it into the top equation or the second one, but this one's going to be so much easier. Take the 11.25 and plug it right in there and solve for W. Okay? Always make sure you plug it back into one of the original equations so that way you can solve for the other. If you're thinking, hey, you manipulated this equation, this is not an original, just notice all I did was bring over the A, so it's a very simplistic version or derivation of what I had originally. So I'm comfortable plugging it into this one. All right, let's turn the page. Let's do it again. Charisse is the owner of a Starbucks coffee shop. She sells blonde roast coffee for $6.20 per pound and pike roast coffee for $5.80 per pound. If she uses 18 pounds of the blonde roast coffee and the mixture of these types of coffee and sells the blend for $6.10 per pound, how many pounds of the pike roast coffee should she mix with the blonde roast coffee? Okay, cool. Set up your boxes. Box plus box is equal to box. We're going to call the first box the blonde because it's blonde roast. And we're going to call the second one pike. And we know that we want a mixture of the two. We also know that for each of these we have a cost, and that's in terms of dollars. And the weight of the coffee is going to be in pounds. So again, it's so helpful to make sure that you have everything clearly labeled before we throw in all the information in here. All right, you know that blonde roast sells for $6.20 per pound, so let's put that here under the cost for blonde. So I'm going to put a check mark next to it because we're done. Pike roast sells for $5.80 per pound. Let's put that right here. Excellent. Then notice what it says. If she uses 18 pounds of the blonde roast coffee, 18 pounds of the blonde roast coffee, that's how much is being used in that mixture. And then she sells the blend for $6.10 per pound. The blend is the mixture, right? So she sells the blend for $6.10 per pound. How many pounds of the pike roast coffee should she mix with the blonde? So that means we don't know how many pounds of pike. So I'm going to call that P. But guess what? We don't know how many pounds of the mixture because we don't know pike. So let's call that M. Always use a different variable because we have no idea if they, actually we know for a fact they are not the same amount. Unless, nope, they're just not. Think of it this way. If you have 18 pounds of the blonde roast and whatever pounds of pike, your mixture is going to be the combination of these two, right? If that were 20, then the mixture is 18 plus 20, which is 38. If this were 5, then the mixture is 18 plus 5, which is 23, right? So you have to consider that they're definitely going to be different amounts. All right, we now need two equations. The first equation we have deals with weight. 18 plus P equals M. Love it, right? 18 pounds plus P pounds equals M pounds. Cool. That's the weight equation. The next equation deals with value. Value is cost times amount. So 620 times 18 gives me 111.6 plus cost times amount, 580p, is equal to cost times amount, 610m. And again, I'm just going to rewrite this to make my life easy and so I could see it clearly. I don't mind spending the 30 seconds it takes to rewrite the problem if everything's nice and neat and organized. Now, if some of you are thinking, it doesn't look like these equations are in standard form, which means it doesn't look like I'm going to be using elimination. Well, I would recommend not using elimination in this case. And the reason for that is we know what M equals. M equals 18 plus P. So if we know that M, when you flip it over and you make the substitution, is 18 plus P, all we have to do is plug that into this second equation for M. So I now have 111.6 plus 5.80p is equal to 6.10 parentheses. Remember, M is being replaced by 18 plus P, and we made our substitution. So all we have to do now is distribute and solve. Let's go through the motions. We're going to distribute that 6.10. So 6.10 times 18 is 109.8. And then 610 times P is 610p. And now I just have to do the math. I have to subtract terms and bring it to the opposite side, and then I'll end up dividing. So I'm going to breeze through this because this is a Unit 2 part. We've done this a million times, and I think we would all be successful with this. Just be really, really careful with all of your decimals as you do this, okay? Be super, super careful. I'm going to continue working through the problem. And notice that I do not have any room, so I'm just going to bring this over here. That gives me 1.8 is equal to 0.3p or 0.30p. It doesn't matter, that's the same thing. And then I divide, and I get that 6 is p. So the question for this was, how many pounds of the Pike roast coffee should she mix with the blonde roast coffee? Well, we just figured it out. She should mix 6 pounds of the Pike roast coffee. Yeah, that's fine. And you're done. Not bad, right? This one looked different because we knew the weight of the blonde roast instead of what we had last time, which is the weight of the mixture. And that's not a big deal. All you have to do is carefully organize the information and put everything where it belongs. Let's do number 15. 15 seems a little bit different because all of a sudden we're talking about percentages, but the idea remains exactly the same. You just have to be careful with converting percentages to decimals. Remember that when you want to convert a percent to a decimal, you're going to divide by 100. Or in essence, you're going to move the decimal 2 places to the left. Okay, so let's take a look. Let's make our boxes. And now let's read the problem. Clorox bleach is 5.25% sodium hypochlorite, and swimming pool shock treatment is 10.5% sodium hypochlorite. How much of each item must be mixed to get 6 cups of a mixture that is 7.2% sodium hypochlorite? So right off the bat, when I think about this, I realize that I have Clorox bleach on hand, so I'm going to call this one bleach. And I also have swimming pool shock treatment. So if you're okay, I'm just going to call this pool. Okay, swimming pool shock treatment. And we're trying to make some sort of mixture. I also noticed that I'm referring to the percent of sodium hypochlorite in each of these things, correct? So I'm just going to call it percent sodium, if that's okay. And then I notice in terms of amount, it's not gallons, it's not liters, it's actually cups for this particular problem. So I like writing cups in there, just so that I know exactly what I'm talking about. Now, all we have to do is fill in the chart with where everything's supposed to go. Clorox bleach, that's 5.25%. So instead of writing 5.25, remember you have to convert this. So this is going to be 0.0525. For the pool shock treatment, it's 10.5%, so that's going to be 0.105. It says how much of each of these, so I don't know, let's call this B and let's call this P. How much of each of those should be mixed to get 6 cups of a mixture that is 7.2%, so 0.072. Now that I have filled this in, I would like you guys to take just a couple minutes to write down the 2 equations that pertain to this problem, and then I would like you to solve it. So take 120 seconds to solve this. All right, so let's see how you guys did. You should have had 2 equations. The first equation dealt with just the weight, so B plus P is equal to 6. And your second equation deals with the values, so 0.0525B plus 0.105P is equal to, now let's take the 0.072, multiply by 6, because remember value is concentration times amount, and you should have had 0.432. Hopefully you guys agree with that. Be very careful. So let's take a look. Okay. So, and Anthony, this is a fresh topic, so we're just doing this for the first time together. So what we're going to do is rewrite these equations. 0.0525B plus 0.105P is equal to 0.432, and I'm actually going to use elimination this time just because I prefer. I really do. So I'm going to use elimination. We want to use the opposite of this number since it's smaller. You're probably thinking 0.05 and then 0.105. This is actually the smaller number, right? Think of 5 cents instead of 10 cents, right? If you cut off the rest of those digits. So I'm going to multiply the entire first equation by a negative 0.0525. Okay, let's see what we get. And again, this is elimination. So we have a negative 0.0525B. Negative 0.0525P is equal to, and remember we have to distribute to all 3 terms. So let's take that negative 0.0525 and multiply it by 6. That'll give us negative 0.315. I don't know if you noticed, but as I write this down, I'm going kind of like slowly in terms of transferring it because I want to make sure that I don't lose any of these decimal values. So we want to be really, really, really careful that we don't accidentally write something wrong. My first pair here, I have opposite terms. These are opposites. These are additive inverses, so they cancel each other out. Gone. Next, I'm going to punch this in exactly as I see it. Again, in case it's helpful, we'll do negative 0.0525 plus 0.105. That gives us a positive 0.0525p. Now let's plug this in. We've got negative 0.315 plus 0.432. That gives us 0.117. All right. Next, we're going to divide both sides by 0.0525. And let's plug that in. Divided by 0.0525. Awesome. If we round to the nearest tenths, we'll write down that P is 2.2. So that's rounding to the nearest tenths place. One digit after the decimal. Now let's look at where P is. P is here under pool shock treatment, and P refers to the number of cups. So we know that there's 2.2 cups of the pool shock treatment. What we want to find out is how many cups of bleach. So what I would urge you to do is to go ahead and take this value and plug it into the easier equation. The easier equation is B plus P is equal to 6. We know that P is 2.2. So why not use that equation, right? It makes sense. So we plug in the 2.2, we'll subtract it from both sides, and we get that B is equal to 6 minus 2.2, which gives us 3.8. So let's write our answer. So the bleach, the Clorox bleach, there's going to be 3.8 cups of that. And then for the swimming pool shock treatment, I'll just call that pool, we have 2.2 cups of that one. And you're done. So even though it seemed maybe initially that this was kind of a scary problem because of all the percentages that we have, it's actually not bad at all as long as you're careful with converting your percentages to decimals, and then as long as you're careful with the decimals themselves as you move through the problem. Just take it nice and slow, and I think you'll be just fine. Oh, and Anthony, we've recorded all of our class sessions, so you have all of the videos on my channel. Go ahead and run through those videos, okay? Excellent. Okay. What I would like you guys to do now is to try 16. I love this particular problem because first it's based on an actual fact. Dylan Proctor, he is a well-known African-American sommelier. So this is an actual person. What I would like you to do is set up the chart, fill that in, and let's go from there. So I'm only going to give you, let's do 60 seconds for you to set up the chart. That's all I want from you. So I'm going to read this out loud. To make an interesting concoction, Dylan Proctor, a well-known African-American sommelier, chooses to combine 2 red wines. He mixes 5 liters of a Shiraz, that is 12% alcohol by volume, with 2 liters of a Pinot Noir, that is 9% alcohol by volume. Determine the alcohol content of the mixture. All I want you to do, like I said, is simply set up the chart. I'm going to give you 60 seconds to do that. And as you're working on it, I'm going to draw the boxes just so that we're not going to waste any time. Okay, let's check this out. So he's got 2 red wines, a Shiraz and a Pinot Noir. We're trying to make some sort of mixture of the two. We know that the top row pertains to the percent of alcohol by volume. And we also know that the bottom row pertains to the number of liters of each. So step by step, don't overthink this. He mixes 5 liters of a Shiraz. So 5 liters of a Shiraz, that is 12% alcohol by volume. Okay, with 2 liters of a Pinot Noir, that is 9% alcohol by volume. Determine the alcohol content of the mixture. By them saying determine the alcohol content of the mixture, that means we do not know the alcohol content. But, guys, if I have 5 liters of Shiraz and 2 liters of Pinot Noir, and I mix those two together, you better believe I have 7 liters of a mixture. 5 plus 2 is 7. That makes sense. Now, the interesting piece about this is that if you look at the entire chart, you actually only have one unknown. Traditionally, we had 2 equations, a mixture equation, or excuse me, a liters or an amount equation, and we had a value equation. In terms of the amount, 5 plus 2 is 7. Duh, right? We're done with that. Which means the only other equation we have is the value equation. Value is going to be concentration times amount, so 0.12 times 5. 0.12 times 5 is 0.6 plus, and Erica, in terms of the structure of your chart, if some of you decide to put liters at the top and then percent alcohol at the bottom, that's totally cool. That's totally cool. Just make sure you have everything labeled so that as you do it, you know where everything's supposed to go, and you also know how to organize your equations. So thank you, Erica, for that question. That's a great question. So next we have the value of the Pinot Noir, so that means 0.09 times 2, and that gives us 0.18. And lastly, we have 8 times 7, so that's 7a. Beautiful. Notice 0.6 plus 0.18. These are like terms, right? If you read that out loud in any other scenario, you would say, oh, let me just add those two together. If you add these two together, you get 0.78. Now we're going to divide both sides by 7 because we're trying to get A by itself. So if I divide both sides by 7, I get 0.111, and I'm going to stop right there because what this means is that if we bring the decimal 2 places in, the alcohol content of the mixture, the red blend, is 11.1%. The alcohol content of the mixture is 11.1%. I'm totally okay with you guys saying 11% if you want. Hyder, you asked a great question. The reason we placed A here in this slot is because look at the word problem. It says determine the alcohol content of the mixture. The alcohol content of the mixture is unknown. So wherever we have an unknown, we'll place a variable. So I just put here, I put an A here to represent the alcohol content of the mixture, which is unknown. All right, I hope that's helpful. What I'd like you guys to do on your own, not today, or maybe today, just now, right now, I want you to do number 17 as a bonus test point. Okay? So number 17 is the bonus test point. I want you guys to give this a shot on your own after class, not right now. Give this a shot and see if you can figure out the percent of pure juice in the concentrate. I would like you to email me your work and your solution, and I'll tell you whether or not you got a bonus test point. Okay? Hyder, you asked another good question. Once our answer is 0.111, remember, we want the percent of alcohol. So yes, you multiply by 100. Good. Beautiful. Let's keep going. We are almost done with the notes. We only have 2 pages left. So notice the header for this section is called miscellaneous problems. So what I'd like to point out for this next section is that these are non-mixture problems. And what I want you guys to get used to is being able to identify when we have mixture problems, when we have distance, when we have simple interest, when we don't have any of those. So this particular section of your notes is miscellaneous because they're not any of those. They're not mixture, it's not simple interest, it's not distance. When we read the language carefully, I think it's going to be super clear why they do not fit into any of those categories. So in which case, we are still in systems of equations, right? That's the umbrella here, systems of equations. So we still have to come up with a way to develop a system of equations and then use either substitution or elimination to solve. So I want to show you 18, and I think it'll be so clear why this is not any of those things. Let's take a look. A vendor sells hot dogs and bags of potato chips. A customer buys 2 hot dogs and 3 bags of potato chips for $6.25. Another customer buys 5 hot dogs and 3 bags of potato chips for $12.25. Find the cost of each item. This is really important. Now, you know it's not distance because we're not talking about driving anywhere, speed, or anything. You know it's not simple interest because we're not investing any money and there's no rates. But how do you know it's not mixture? Well, I don't know about you, but would you ever take your hot dog, chop it up, and put it inside of your bag of potato chip, mix it up, and then eat it? That sounds disgusting. Would any of you take your potato chips, crush them, and stuff them into your hot dog? Probably not either, right? You also notice the word mixture is nowhere to be found. So this is not a mixture problem. Instead, because this is asking for us to find the cost of each item, why don't we say that H is the cost of a hot dog? And let's say that B is the cost of a bag of chips. Are you guys okay with that? H is the cost of a hot dog, B is a bag of chips, right? So word for word interpretation, I think you're gonna like these particular problems quite a bit. So it says a customer buys 2 hot dogs and 3 bags of chips for $6.25. Just like that, we have our first equation. Another customer buys 5 hot dogs and 3 bags of chips for $12.25. Bam, you just found your system. My advice for you guys, for this particular system, I would use elimination. I would not, and I repeat, definitely not use substitution for this. Okay, let's use elimination. I want you to notice that these are the same 3b and 3b, but in order for them to cancel, one has to be a negative. I'm going to choose to multiply the top equation by a -1 so that these will end up canceling each other out. So let's multiply the entire top equation by a -1 and let's see what we get. So I've got -2h, -3b, and a -6.25. Put the second equation directly underneath. Now let's do the math. -2h plus 5h, that's 3h. And -3b plus 3b, those are opposites. They eliminate each other, which is exactly what we wanted. -6.25 plus 12.25, when you do the math, you'll get 6. Divide by 3, and you just found that h is 2. Recall that h represents the cost of a hot dog. So we know that the hot dog costs $2. We're not done. We still need to find the cost of a bag of chips. So we are going to take this dollar amount and plug it into either one of the originals. It doesn't even matter. I am going to plug it into the second one just because. So I have 5 times h, and h is 2, plus 3b, is equal to $12.25. 5 times 2 is 10. Let's subtract 10 from both sides. We have 3b is equal to 2.25. And then we just divide both sides by 3. And you get that b is 0.75. I hope I didn't move too fast through that. But that's the beauty of these videos, right? You can always go back and then rewatch it. So let's write our answer section. Hot dogs cost $2, and bags of chips cost 75 cents each. And that's it. That's literally all you have to do. We don't need a chart here because it's not any of the types we've seen so far. It's not distance, it's not interest, it's not mixture. We go right into writing down our equations and moving forward from there. I would like you guys to take 2 minutes to do number 19. However, I would like to use the same variables. So a vendor sells beef jerky in bags of popcorn. So why don't we use B for the cost of beef jerky? And let's use P for the cost of popcorn. So I want you to use B and P. A customer buys 4 bags of beef jerky and 4 bags of popcorn for $13. Another customer buys 3 bags of beef jerky and 2 bags of popcorn for $9. Find the cost of each item. Go for it. 2 minutes starting now. All right, let's see the results. We've got some answers coming in, which I love. So let's take a look and see how this goes. So we have 4 bags of beef jerky and 4 bags of popcorn sold for $13. And then we have 3 bags of beef jerky and 2 bags of popcorn for $9. You could choose to eliminate either B or P. In this case, I'm actually going to choose to eliminate P since this is already a 4P, a positive 4P. So I can easily turn this into a negative 4P by multiplying the second equation by -2. So hopefully you guys are okay with that. That gives me 4B plus 4P is equal to 13. Let's distribute the -2 throughout. So we get -6B minus 4P is equal to -18. Notice my P's will eliminate, which is exactly what we wanted. 4B minus 6B is a -2B. 13 take away 18 is a -5. And then we divide both sides by -2, and we get that B is 250. So nice job. Nice job with saying that it's $2.50. Hyder Brittany, excellent. Okay, once you have the cost of beef jerky, let's plug it into one of the original problems. So I'm going to go ahead and plug it into the first one, just because I feel like using that one. We don't have to use this one, of course. We know that B is 250, so it's 4 times 250. Okay, we know that double 250 is $5, so quadruple 250 is $10. We're going to subtract 10 from both sides. We get 4P is equal to 3. Divide by 4, and we get that P is 0.75. Because remember, we're talking about money, so we could definitely write our answers as decimals. So the cost of beef jerky is $2.50, and the cost of popcorn is 75 cents. Nice job, everyone. Very nice job. Hyder, that was excellent. We have one more page left. 2 more problems, and we're done for the day. So let's see it. A movie theater charges $8 for adults and $5 for children. If there were 40 people altogether and the theater collected $272 at the end of the day, how many of them were adults and how many were children? So we always start with the question, right? How many of them were adults and how many were children? So why don't we call A the number of adults, and why don't we call C the number of children? Now, let's think about this logically. We know that for every adult ticket, it costs $8. So if we had 5 adults, we know that that's $40 right there, right? For every child, the ticket costs $5. So if we had 10 children, that's $50 right there, okay? Now, we don't know how many of each type. We don't know how many adults. We don't know how many children, but we do know that there were 40 people total. So wouldn't it make sense to note that if A is the number of adults and C is the number of children, that altogether you have 40 of them? Wouldn't that make sense? So this first equation deals with how many of each type. There are A adults, there are C kids, and there's 40 people total. Your second equation has to deal with money. So it's $8 for every adult. I like to put that dollar symbol in there just so it's a reminder that, oh yeah, we're talking about money. So it's $8 for every adult, $5 for every child. And notice that we were told how much money the theater collected. The theater collected a total of $272 at the end of that day. Okay, because there were only 40 people who went during that time. I'm hopeful that this setup makes sense. You want to be very, very careful that you don't accidentally switch these two numbers. You do not want to say that the number of adults plus the number of children equals $272. That's pretty harsh. That's pretty harsh to say that a set number of adults and kids only are valued at $272. That is rough. So don't do that. You want to have an equation that deals with the number of people, and you want an equation that deals with money, because that's what we're talking about here. So we want to do this logically. We want to do this carefully. At this point, all we have left is to solve, to use elimination. I want you to notice before we go through the motions that this definitely is not a distance problem. We're not talking about miles or speed or time or kilometers. We're not doing any of that. We know this is not simple interest because we don't have any growth rates for two accounts. We don't have that happening here. We also know this is not a mixture. Are you going to put the adults in the children and the children in the adults and like cut them up and put them together? No, that's gross. That's terrifying. Don't do that. It's not a mixture problem. Okay? So if we rule all of those out, we notice that, okay, what is happening here is that we have two unknowns, so we need two equations. We need to set up a system and solve it. I'm going to go ahead and solve this guy for you, and then I want you guys to do 21 at home. I will choose to multiply the top equation by a -5. That's my personal preference. I want to use elimination. So remember, we must distribute to all three terms. That gives us -5a, -5c is equal to -200. We're going to bring the second equation right over, and we're just going to do the math. Notice my c's cancel out. This is what I wanted. I wanted them to eliminate each other. -5a plus 8a is 3a. -200 plus 272 is a +72. Divide both sides by 3. And if we take the 72 and we divide it by 3, you should have 24. So just like that, I found the number of adults. We know that the total number of people is 40. And if there are 24 adults, all we need to do is figure out how many kids. So if we show the steps to doing that, we find that there are 16 kids. So my answer will be 24 adults and 16 children. And we're done. That's it. Go ahead and take care of 21 on your own at home. I would urge you to use A for the number of adults, and I would urge you to use C for the number of children. Set up your system, solve it, and let me know what you get. Excellent job today, guys. It was a pleasure working with you as always. Please stay safe, please stay healthy, please stay home. All right? In that case, I will see you all on Monday for a tutoring session or Tuesday in class. All right? See you guys.